My name is Emily Brennan, and today we're going to be looking at mathematics education, if it should be changed. So this is a very debated topic, and it has been since essentially the beginning of mathematics education in the U.S. because society can't determine what the best way to teach mathematics is, such that students best understand it. So today we're going to look at how mathematics is taught, how mathematics instruction in the U.S. has changed over time, technological advances and how they impact math education, the weight the subject carries on people, and if there's a problem with mathematics instruction, how we as teachers can fix this. So first we're going to look at why we learn mathematics. So this is a debate, and especially because most people don't go on to use higher order mathematics in their professions or everyday lives. This means that they're not using math beyond arithmetic. And according to the Asia Society, a nonprofit organization who's looking to connect Asia with the rest of the world, mathematics can help students to comprehend the world and solve real-life, intense problems. We also learn that learning mathematics helps us to problem solve and reason to reach the truth. So then we're going to look at the history of math education in the U.S. So this was a nice quote from Larson in his article, on his PowerPoint, that Americans live in the shadow still of the ideas and stereotypes about arithmetic first articulated in the 19th century. We learn that history tends to repeat itself and that people are constantly debating and criticizing whether the best practice for instructing mathematics is through memorization of mathematical procedures or by having students learn through discovery in order to better understand mathematical concepts. And we can see a lot of these parallels between then and now, as they're still continuing to go on. So teaching mathematics has changed over the years, and it's still currently changing. Then we see technology's impact on math education. So as technology advances, we learn that people tend not to rely on their arithmetic skills as much, and this, in fact, calls many mathematicians today are those who are able to use technology for carrying out mathematical procedures effectively and efficiently. We also learn that tablets and computers have been found to be highly effective in engaging students. As we look at what our mathematics curriculum is today, we learn that the Common Core state standards guide each state's mathematics curriculum. And this curriculum is set in place in order to allow teachers to concentrate on fewer selected topics that can be easily introduced, are not very abstract, and a majority of students are able to relate to. So the mathematics curriculum today in the U.S. consists of arithmetic, geometry, elementary algebra, probability, and statistical distributions. You can see that calculus is not involved on this list because while it is offered in some schools, oftentimes students don't grasp the whole concept of calculus because there's not enough time. It's too abstract to learn it. So then we're going to look at, are we teaching mathematics effectively? So research has shown that many are put off by mathematics and have math anxiety due to stressful environments and traditional teaching methods of repeated practice problems. This can cause many people to just avoid mathematics, and then they in turn grow up and teach their children that math is an incredibly hard subject and they should avoid it. So we learned that drilling students in memorizing mathematical procedures does not allow for students to understand that math topics are connected. And it also leads many students to drop out of high school, but we'll look more into that statistic later. So mathematical thinking should be the focus of math education instead of this toolkit method of mathematics instruction that oftentimes exists. This toolkit method is when students are just expected to learn rules and learn procedures, which goes back to how students don't learn that these math topics are connected. So now we move on to the statistics of math education in the U.S. We learned from Wolpert that 60% of high school graduates in the U.S. entering community college are not prepared for college-level mathematics courses, leading many to not graduate from college. This means that a lot of potential is lost from people. A lot of people's lives are thrown off because they couldn't pass math. So analysis of this research shows that mathematics instruction in America favors the memorization of steps and disconnected facts without deep understanding of topics. And Hacker found out that 1 in 4 ninth graders drop out of high school because they fail algebra. And 42% of college students do not attain their bachelor's degree due to freshman year mathematics courses. This can be because of math anxiety or because they fail the course and can't get through it. So now that we've learned that, we're going to look at the better strategies to teach mathematics, to help with the math anxiety and to help students have a better understanding so that they're not dropping out of school. One strategy is real-world connections. In this strategy, we learn that students' perception of mathematics is greatly influenced by their performance in the subject. We also learned that one tactic is that we can develop flexible lessons with context that students are interested in. And then these connections will allow students to become inquisitive learners, enhance their motivation, deepen their understanding of concepts, and they're beneficial to the attitudes towards mathematics, thereby lessening the math anxiety. Real-world problems often have multiple solutions, which means that students can analyze the different methods it takes to get to those solutions, which boosts their critical thinking skills. Another way is interdisciplinary lessons. So interdisciplinary lessons are when teachers double dip in teaching subjects such that they're connecting mathematics to other subjects such as math or such as art, music, science, and even social studies, and it builds a deeper meaning of mathematics for students and allows them to connect to it more. Another strategy is group work. Here, students can work in small groups or as a class to inspect problems, come up with methods on how to solve these problems, and determine what the best method to use is. And then they can explain why this method is the most efficient. So this tactic engages students and it's beneficial to their critical thinking skills, confidence in their mathematical skills, and to their math performance. It also shows students how they can improve upon their math skills, as well as how these lessons will be used later in life, because they're making more connections to them. There's some extra techniques that teachers can use in their lessons, and these are sharing with students the parts of mathematics that they like, which will boost the students' enthusiasm and demonstrate to students what their passions are, which is building more connection both to the students as well as having the students connect more to mathematics. And then we can also find mathematics in current events going on around the world. We know that mathematics is in everything around the world, even if we can't see it at first. So Devlin searches for this idea, and he sees that we can do this, and it can connect to social studies as well. And here are the works cited. Thank you.